If you've ever seen a car suspension, and especially a wacky spring like this, and thought, what is going on? You're not alone. Did you know that using progressive springs can make your car low without it feeling terrible? Or how they can help trucks cross over varied terrain? Well, today I'm going to take you through how progressive springs work and why people use them. A car suspension is made up of two key components, springs and dampers. Springs provide a force when the tire is moved up or down, like when you ride over a bump on the road. When your tire hits a bump, the spring compresses, providing a force that pushes the tire back to the ground. This makes sure your car's tires spend the most time on the ground possible, which keeps you safe. Dampers work together with the spring by slowing down the movement of the suspension, keeping your car's body smooth and comfortable. Traditional linear springs appear like the image on the left. They have coil windings with equal pitches or distances between each loop. They provide a force that increases linearly the more you compress them. If you squeeze a linear spring 1 inch or centimeter, it requires a certain force. In order to squish the spring another inch or centimeter, it will take twice the force to achieve this. Progressive springs, also known as nonlinear springs, on the other hand, behave differently. Progressive springs provide a force that does not increase linearly with distance. Instead, progressive springs start out with a very low force required to compress them, but then the force required increases dramatically. This can be seen more easily with this visual demonstration. As you can see, the linear spring provides a force that is proportional to the distance it's squished. The progressive spring starts off producing less force than the linear spring, but at a certain point, the force increases to which it's greater than the linear spring. This occurs because the coil windings with a smaller pitch, or distance between each other, compress easier, since they have more material length for a given distance. When bending a longer object, it is easier because each piece of the object doesn't have to be strained as much. To help understand this concept, think of two metal bars, one short bar and one very long bar. If you had to bend both bars a certain distance, which one would be easier? That's right, the long one. You were thinking the long one, right? The long bar is easier because you don't have to bend each section of material as far. This is why the closer packed spring coil windings are, the easier it is to compress them. One more thing before we look at how springs affect ride quality. When you compress a nonlinear spring, the closely spaced windings compress easily first, but once they touch each other, they can't compress any further. This means the other windings with larger pitch have to compress, which causes the dramatic increase in force required to squeeze them. Now, on to how spring choice affects your relaxing Sunday cruise. Say you, yes, that's you, or you in your friend's car, have an average car and you've never touched the suspension. You're rocking the springs and dampers your trusty car manufacturer gave you. Good for you for being frugal and responsible. Car manufacturers have spent lots of time, money, and engineers' weekends making sure your car works well with the springs it installs. Linear springs with a normal ride height allow your car to drive over both small and large bumps with ease. The large distance the suspension is able to travel allow for a softer spring, which is able to be compressed by both small and large objects without excessive forces on the car, and therefore, look at how happy you are. This large spring travel and soft springs are great for keeping you comfortable and keeping the tires on the road. But there are some downsides to this setup. Soft springs allow the car to rotate more, meaning when you're turning, braking, or accelerating quickly, the whole car will start to lean sideways, forwards, or backwards. For making a car fast around a track, this is bad. Additionally, most cars come from the dealership with a ride height designed for comfort. For performance, a lower ride height is ideal. So now we've come to a problem. If we want to make our car fast and comfortable, what should we do? The first choice you try is using the same soft linear springs, but reducing their height, thereby lowering your car. With the same soft springs, you're fine going over small bumps, happily cruising with low forces on your body. But if you hit a large enough bump, the soft springs won't be able to provide enough force and your car will bottom out or scrape. Bottoming out is that terrible experience when your springs compress completely, resulting in all the force of a bump going into the car and then into you. Equally as bad, the soft springs don't provide enough force to stop your car from scraping its beautiful bumper on that large bump. How tragic. There must be a better way. You remember your trauma, and in order to never bottom out your car again, you try out the same length springs, but with much more stiffness. Now when you roll over bumps, your car will never bottom out or scrape. But you feel every single pebble in the road through your car seat. Because the springs are so stiff, they supply very high forces for even small bumps, causing your car to feel like you're driving on a freeway in a shopping cart. Sure, you'll never scrape your bumper, but the high forces make driving your car unbearable. I wonder if there was a combination of soft springs with small bumps and stiff springs with big bumps. Oh wait, that's what we were just talking about. With your new fancy progressive springs installed, you can't be stopped. Small road bumps result in minimal forces on the car, keeping you comfortable as you cruise the neighborhood streets. If a large bump comes, the progressive springs dramatically increase their force as they are squished, preventing your car from scraping and from bottoming out. With this setup, your car is lower, but still comfortable enough for a cruise on the highway. Now, although progressive springs can provide great benefits, optimizing suspension is a complex process involving tuning between your springs and dampers. But for lowering an unmodified car and keeping the ability to drive comfortably, progressive springs are a great option. Thanks for making it to the end of the video. I hope you learned something today, and if you liked the video, leave a thumbs up. I'm just starting out on YouTube, so I'm open to suggestions for more car or engineering videos and any general feedback. Thank you.